Hello, everyone. We are back here at the Azure channel with Stephen Murawski and Vic Perdana. Hello, everyone.
Hello.
Hey, how's it going?
Very good, very good. Great to have you both here. Vic is a CSA here from Melbourne. We're both in Melbourne. Stephen in US. And Stephen is going to join us today to talk about WebAssembly and how is that going to change a little bit. What's the feature of like web development? What the feature of like assembly in general? And what's his vision for the future? Welcome. And present yourself, Stephen. I think many people know you from the DevOps time, but welcome. We're both from the Azure Cloud Developer Advocate team. I'm very glad to be on your team now. And we work on the Cloud Native team. And yeah, welcome to the Azure channel. Welcome, Vic.
Thank you very much, George. Yeah, I'm very excited to be working with you on the Cloud Native team, and it's great to meet Vic. So I'm Steve Murawski. I am a cloud advocate, and I previously was on the DevOps team. Now I'm over on Cloud Native, and in Cloud Native, you often think containers. Well, there's other stuff in the Cloud Native ecosystem other than containers, though containers are awesome, and this is not a container killer or anything like that we're going to talk about. But it is another tool in our toolbox as we look at Cloud Native workloads. And we're going to dive into WebAssembly, and that's what I've been kind of looking into and learning. And now I'm by no means the ultimate expert here on this, but I have been doing a little bit of research, and have been doing a little bit of digging around, playing in some of these projects. And so I'm really looking forward to being able to share a little bit with you, George, and with you, Vic, and then with everyone who's joining us on the Azure Tar channel to a little bit about WebAssembly and what we can do with it.
Sounds good, Vic. Sounds good to me.
Thanks a lot. Absolutely. Looking forward to it.
Great. So should we dig right in?
Yep, let's go. You can share your screen. And
all right.
Yeah, we're excited to see what you have to show to us.
So the root of this really started around a blog post series that I wrote back in let's get this going here, back at the end of last year, and it was called "Getting Started with Hippo: A WebAssembly Paths," and I'll make sure you have the links for this, George, that we can put along with
Sure.
it. But one of the things that we had to do as part of that was come up with and define a whole bunch of things, because WebAssembly is, when people think of WebAssembly, we think of our browser, and we think of high performance JavaScript, right? It's not high performance JavaScript, but it is in runtime that is available in our browsers for more efficient, higher performance workloads. It interacts with and can work with JavaScript. Right, so WASM or WebAssembly is a compact, low-level language. There's a binary format and a text format, and but what we found was, while this engine was built to run in a browser, it's not only for a browser, or it can run outside, and so what that led to was a number of different projects looking to host WebAssembly, and those projects included things like and what eventually became WASI, or the WebAssembly System Interface, which is a standard being developed by the Bytecode Alliance for how the WebAssembly engine can be exposed to underlying operating system resources. And so it gives you a standard runtime across platforms or wherever you might be running, and defines how WebAssembly can expect to access system resources. And it's a controlled sandbox. So if I wanted to expose file system resources, the WASI standard says how WebAssembly can expect to access those file system resources. Same thing with any of your operating system environment. Now, do you have a question, George?
No,
Okay.
yeah, I really enjoyed that
Yeah.
that conversation. Many people we're going to get there on the Blazor side, and that for the .NET people watching, just wait. We're going to discuss Blazor there. Hang on with us.
Yes, definitely. We'll definitely touch. Oh, sorry. We'll definitely touch on Blazor. Now, but before we get there, I started talking about the standard of WASI, and there's a reference implementation, WASMTIME, and that underlies a lot of the stuff that we're going to look at today. Is we're going to build stuff for the WASMTIME runtime, and we're going to and things that build on top of it, including you can probably tell from my image, I'm old, and so I remember things like CGI, where we would, hook up Apache web servers to talk to PHP or Python or all these different apps. And so that was the common gateway interface, which was a way to take things that didn't listen for web requests and make them accessible via the web. Well, there's a project, the WAGI, or WebAssembly Gateway Interface, which takes that standard, the CGI standard, and provides that as a way for WebAssembly, which the standard right now does not have, though there's a PR to bring that support in, does not have socket support for inbound connections. So you can't create a web server, for example, in WASM yet. It's there's sample implementations, there's a draft, but it's not all landed yet, right? So it's coming though. But in the meantime, we have WAGI. We have this common gateway interface as a way to take requests in and be able to run our WebAssembly code and provide responses back. There's a lot of other stuff that could fall into this ecosystem, but I think we can talk about a lot of that if we look at a project. And one of the ways that I like to start my projects, and we'll go over to Visual Studio Code. Right now, I am actually SSH'd into a little dev machine that I use, and so I've got all my tools and stuff installed there. I've got Rust, I've got Node, a few other tools and things in place. But we're going to open up a terminal, and so I am going to go into my Hello Azure Tar folder. There's nothing up my sleeve. I got nothing in this folder structure. We're going to use a generator called WASM to create my project. And it's a great tool to help us get started. And before I tell you all about it, we'll start the tool, and I can tell you as we go through, because the tool asks a lot of questions and gives you some options, and you can see what's actually all available. So, WASM. Excuse me, just take a little sip. It asks us what. Yeah.
I'm just going to comment. If you don't know what is a Yeoman, is a tool. I think if you never use Yeoman, but that's the U at the beginning.
Yeah, I used that before for creating a Visual Studio Code extension as well. I think they use that for creating something like that, which is good.
Yeah, it's very good.
Yeah. Yeoman's a really popular tool for generators because it supports a templating engine, so it can kind of scaffold out files and things and take information. It can ask you questions and then use that to generate the right stuff. It can also call APIs and run commands and do a lot of other fun stuff. In this case, we're mainly going to be leaning on the file, the kind of the code generation part of it. So it's going to ask me for my name of my module. It infers a name based on the current directory, or you can provide something else. So I'm just going to call this Hello Azure Tar. We'll just do a little underscores there and separate it, and it's a little friendlier for the WASM. And my compile won't yell at me later for having something that's not cased properly. And so we could be creating a console or batch job or a web service or application using WAGI. Well, I've just been talking about WAGIs and WAGI and WASI. That's one of the reasons I wrote the first blog post when I started talking about this space, because there's a lot of terminology and there's a lot of acronyms, right? So WAGI, that's our Web Application Gateway Interface. That's our CGI experience for WebAssembly. That implements the WASMTIME runtime with that common gateway interface. So all these things are connected and they all kind of build on each other. So we're gonna do web service or application. What's the name of the author? It's pulling that from my Git config, I believe. You can obviously change those things. I just took the defaults. Then it's going to ask what language would you like to write the module in. Now, if you install Yeoman as of today, or not, sorry, I'm sorry, not Yeoman. Yeoman was a Yeoman generator for working with Azure DevOps and Azure DevOps Server. If you install WASM, yeah, sorry, a little bit of history there. All right, if you use WASM, it's going to ask you what language you want to write your module in. If you install it today, you probably won't see TinyGo. I'm running off what's currently in main in source because I just helped contribute a little bit to that. And so I just want to make sure people see that that's there. It's coming along. Next time there's a release, that will be available in general. Otherwise, you can install it from GitHub and get there. There's instructions on how to do that in that repository. We're going to scaffold out a Rust project because I happen to like Rust, and I think the examples, any of these examples are going to be very straightforward because it's really just a hello world that's going to get created. But it's going to create it with all of the stuff that you need to be successful getting that hello world web WAGI implementation done. So we're going to do Rust.
It's going to create all the components needed to run that. Yeah. Yep.
And I'm going to show you I'll show you some of the fun stuff that gets created with it as well. All sorts of bonus stuff. And so we're going to get the Azure Container Registry. Hippo is a runtime, and that's what the whole blog post actually goes into. So I'll leave that for an exercise for the watcher if you're interested in that. But we'll go to Azure Container Registry. And my container registry is WASM repo, because that's pretty much all I'm storing in it. So it is going and creating some files. And I had already written some down, so it asked me about overwriting some things. But it went through and created or validated that I had a git ignore. It created the cargo toml for my project, looked at a couple of other things. It created my source file, and it created some GitHub Actions workflows. So then it spits out some instructions for us. So, hey, if you want to build this project, here's some of the dependencies that you're going to need, and here's how you can build it. Now, if you want to set up some CI, here are the variables that are defined and the secrets that you need to set up, and some instructions about how to go do that. So it's setting you up as far as it can. So, and if we would go look, we've got a .github folder. It's got a build and release, and apologize. So it's got a build and release for this project. So you're all set up to kind of have that whole DevOps workflow with your WebAssembly project. Well, all right. Any questions so far?
So basically, it's really up to you how you take this on. You can just not apply or go ahead with CI builds. You just want to use the piece of code that you want and just integrate it with whatever CI tools that you use, right? Your choice. But in this case, you got that pre-selected or predefined GitHub Actions and ACR as one of them.
Yes. So there is a tool out there called it's WASM to OCI. And it is a tool that helps you take a WebAssembly assembly and wrap it such that you can submit it to an OCI compliant or an OCI repository like Azure Container Registry. Docker Hub does not support this yet, but there are several other repositories that do, and so you can push that container artifact, and then that's how later we could look at how this integrates with Azure Kubernetes Service. We probably won't get there today in this exploration, but it sets us up for that kind of capability. Now, and yes, it is all opt-in. If you don't want to use GitHub Actions, you don't have to use GitHub Actions. The project here is actually all set up for us to work with locally. Now, I mentioned this is a Rust project. Now, so brace yourselves. We're going to get into some really low-level code here.
Let's go.
Now, have I blown you away? Really, this is as simple as it gets. Right, like this is a really basic hello world example. We can see from we can pretty much infer from the thing here, print line, it's going to print that content, right? And because we're following the WAGI, the WebAssembly Gateway standard, the CGI standard, we can print headers, and then we can print a blank line, and we can print our body of our response. And so that's all that's happening here is we're setting up to run this thing, right? Now, because this is Rust, I could compile something like I could compile this to a native executable, or we can compile it, or we can change our target and compile it as WebAssembly. So let's do that, right? So we've got an instruction here, cargo build WASM. Now that's not a native command for Rust. There's cargo build, but part of the generator established this little setting here, cargo toml, and it defines an alias of build WASM, and it's just going to tell us to build against that WASI target. And that's all it is. That's all it does. But we get to take advantage of a nice little convenience helper, a convenience wrapper that was provided by this project being set up. I told you there was going to be a couple little surprises. Well, we have all the GitHub Actions workflows, and we get this nice little helper for cargo. So when I build this, it goes and there's not a whole lot to do because there's only just the print lines. It creates for me now in Rust we get our build outputs in this target, WASM32, WASI debug, and we have this hello Azure tar WASM. It's a binary file. We can actually run that. Let's do WASMTIME target 32 WASI debug hello Azure tar WASM. And it will print just like what we expected, right? Nothing too major, nothing too exciting there. Now, the interesting part comes in when we start being able to, bring in all the different libraries and things in the Rust ecosystem, and we can build, and so we can bring things that were not necessarily intended for WebAssembly runtimes into that, right? As long as the things are not accessing something that is not supported by the WASI standard, right? You're not making API calls that are not present. You're going to be pretty successful. So a lot of the things that are around data manipulation are probably going to work just fine, right? So that opens up a whole lot of the Rust ecosystem to being present in WebAssembly, and we're starting to see other languages now too. So Ruby has a PR out for support to build for WASM for the WASI standard. Python has announced support for that. .NET has made some announcements around Blazor recently, right? And its support. And now I know George, you mentioned Blazor a little bit ago. Vic, is Blazor interesting to you at all, or of interest?
I think more for George, but yes, I did do good .NET as well in the past. So yeah, that would be interesting.
So it is for me, Steven. I think is a framework that the .NET community, is really investing time and yeah, I like myself and I'm following since the beginning. And just I have one question here. Say the first thing someone looking is, okay, you scaffold your code, you compile that with your compiler there, and now you have like this runtime. How does that compare with like a native Rust or like a native Go in terms of performance of the application running, like the WASMTIME compare with like a native Go binary?
Yeah, so Go I couldn't tell you. For Rust, it's near native performance. There's a little bit of overhead because you're running in a runtime, but it's pretty lightweight. Now we're just printing a couple of things here, so I would probably look at doing something a little more data intensive before I compared. I haven't done that comparison. I should do that comparison and come back to you with some numbers and take a look and see. But it is a lot more performant than if we were doing something in like an interpreted runtime.
That's great. Yeah, next video maybe we can bring some performance testing, and it would be nice to see that.
Yeah, and to be really clear, right? Like this ecosystem is very, very new. There's a lot of rough edges on tools, but it's worth kind of taking a peek at and exploring and starting to understand some of the concepts, because the WebAssembly runtime is extremely lightweight. It will run well in a lot of scenarios where you have limited compute processing or where you need really high compute density. So think, you have some older hardware, or you have a fixed amount of hardware and it's hard to get new stuff. Well, WebAssembly makes it a lot easier to run a lot more workloads on the same hardware. Or you're talking about edge, right? Whether it's you're at an edge like with the CDN, you're at an edge. You've got some Raspberry Pis running somewhere. You've got some smaller hardware running somewhere, and you want to push some workloads out. WebAssembly works out as a runtime, works very well for that because you don't need a lot of resources to do this. I've got a little Kubernetes cluster running on some Raspberry Pis here in my office, so I can test how WebAssembly works in that kind of experience, because you can run more WebAssembly workloads in a smaller footprint. And so that's why it's kind of worth keeping an eye on, because as our application environments start to change and we start to look at more at edge, and we start to look more at high density, this becomes a very interesting way to run our applications. And the WebAssembly that I build on my laptop running Windows, or on my VM running Linux, or on my Raspberry Pi, which is running Linux and an ARM platform, ARM64 platform, right? Like those are that's the same WebAssembly binary. Build it, run it anywhere. Right?
It's very fascinating. I'm just looking at a very quick search. One of the thing that you mentioned was around porting old application to web, right? It can enable some of those legacy that don't run natively in web, and you can expose that using WebAssembly, which is fascinating. Yeah, that's very good.
So one of the projects that I'm playing around with is New Shell. It's a shell written in Rust, and there's a WebAssembly build for it. And so you could run this console. Console or shell in pure WebAssembly. Now, Now, I started talking about Blazor a little bit, and we sort of detoured away from there. And I just want to come back and touch that because it's one of the most common questions that I get is, hey, WebAssembly, that's Blazor stuff, right? Sort of. So with Blazor, we have an implementation on top of WebAssembly. So there's a runtime that's provided for Blazor on top, and so we're giving some interpretation at runtime of traditional Blazor code. Well, they announced that they have now this ahead of time compile, and ahead of time compile really lets you get actual full WebAssembly, and so so you might miss out on some runtime optimizations, but you're taking the optimization path of I'm going to go down to pure WebAssembly and maybe get a little bit more performance on some standard workloads than having that late binding and get the the experience of the interpreted runtime. There's trade-offs, right? There's some trade-offs and things there. But what the ahead of time compile also enables is that I can get that WASM binary out, and we can now look at targeting the WASI runtime, because the WASI runtime is different than the runtime in the browser. Right? There's going to be different APIs available. My browser exposes certain things. That's one place where the WebAssembly runtime is hosted. WASMTIME and other runtimes are another area, and so we want to target that interface so that my standard libraries know where to go for calling things. And when we build that binary. Now, with the ahead of time compile, we've opened up that opportunity. There's actually a demo floating around out in the internet of Blazor building something to target the WASI WASM32 WASI target and running in WASMTIME. So that is awesome to see. So that means that is moving that direction. And so if you want to bring your .NET skills, because you might have noticed we didn't have C# in that list. We had C and we had Rust and we had TinyGo and some other things, but we didn't have C#. Well, it's coming, right? We're gonna see that area develop, and we're gonna see that capability being available. So, all right, I just been talking a whole lot. Any other questions before we move on to look at some other stuff?
Yeah, I was trying to remember. Let's see, for many years, browser was a JavaScript runtime where you could run JavaScript in a sandbox, and that's your browser. You don't have access to the local computer resource. And I remember when the WebAssembly came, the first use case was like gaming.
Yeah.
What kind of use cases here? Like, would be the web application that we're talking about, would be running like a full game binary in a browser, and what kind of the normal use case that you see people looking like containers, like we're going to discuss here with Crosslet? Is anything else that you see or heard about how people are looking to use like WebAssembly and why people need web? That's the first question I get a lot as well. Why need that? Yeah, why need to go back for runtimes? If you have, like native binaries like Go and things like that.
Yeah. So a lot of it comes down to portability of the workload, security of the sandbox, right? Like the WebAssembly sandbox is pretty tight. And so if I build a native executable in Go, it's got the whole operating system sitting in front of it, right? If I do that in WebAssembly, it has what my WebAssembly runtime offers up to it. It may offer a view into part of the file system, or it may offer some environment variables, or it may allow certain remote connections. But the runtime has control of all of that, right? Regardless of what my application asks for, if the runtime doesn't offer it up, it's not going to be available. Well, my runtime for most of my native applications is the operating system. Right. So it provides you a way to run in a much more sandboxed fashion. That's one reason people might look at it. Another comes back to that the system resources idea, right? If we have a small set of devices, right? I could maybe run a container on it, but I could also run WebAssembly. But to run the container on it, I got to make sure I have a container that's built for the right kernel, right? For that device. So maybe I'm targeting ARM64, or so I have to have some of that targeting done. Where the WebAssembly binary it's the WebAssembly binary, right? The runtime handles all of the interaction with the host operating system, and so you don't really care about what it is that you're actually going and running on. Startup time. WebAssembly, it's got a really short startup time. So looking at comparing it to like the containers, there are advantages and there are disadvantages to WebAssembly workloads. It will fit for certain business cases. It will make sense for for a certain number of scenarios. Think edge routing, right? Like how can I put some dynamic rules in place at the edge to help improve application experience? WebAssembly is a very lightweight way that can respond quickly to make some of those rule evaluations on incoming requests without adding a whole bunch of latency. Okay. So that there's a number of different places that WebAssembly could make sense. And compute density and comes back to, right? Like I've got a lot of old hardware. How do I repurpose that to be more efficient and take advantage of what we're working on? Today. So yeah.
So in a nutshell, it's higher level of abstraction than containers, right? Where you basically hide all of those details around the operating system, the target architecture, and so on, and just focus on that WASM executable in a way. Yeah. Yep. So I also read that Solomon, who created Docker, saying that if WASM and WASI existed in 2008, he wouldn't have to create Docker. So it's kind of interesting the way he said it. Probably very, very.
Yeah, I think he came back kind of defending that statement a little bit and kind of mitigating it a bit. Like, we have a multitude of problems in our ecosystem, right? And containers help solve some of them. We used to deploy an application per virtual machine to get isolation. Well, containers help bring some of that isolation, so now I can improve my compute density, right? And I can take more full advantage of, we started running on hardware, then we went to VMs. Went from VMs, now we're into containers, right? But I still have stuff running on bare metal, and I still have stuff running in virtual machines. It hasn't completely eliminated, containers haven't eliminated the need for those things. It's shifted, and as business priorities and technological needs have changed, we've shifted to adopt more or less of one or the other of those things. WebAssembly provides us yet another tool in that toolbox so that we can make a determination of what level of performance do I need, what level of compute density, what level of response time, what level of ecosystem of tooling do I have to have and maintain. What does scaling look like? Like we get more levers, right? Yep. What this does is it makes it harder for architects, right? It gives developers more choice and makes it harder for architects, right? Because now there's another thing you have to bring into your evaluation of, all right, as I'm looking to build out our solutions, where does this fit? And so architects, I'm sorry, but hey, developers, business folks, congratulations, right? You're getting more options, and that tends to lead to better solutions.
Yeah, I still have developer heart anyway, so all good.
Yeah, one thing that got me excited with WebAssembly is the use case where you can hook WebAssembly with as extension for something like proxies, and like you said, as a rule, I can void proxies using that. Then you can write things in WebAssembly in any language supported, and you can write your code as an extension for these, like API gateways as well. And we're going to see a lot of growth on the ecosystem around WebAssembly as like extension assembly for many products, I think.
So I'm also going to show you just so you can kind of see how low level the WebAssembly stuff looks. So I've installed some tooling from the WebAssembly Foundation, which provides extension into Visual Studio Code to convert the binary to a WebAssembly text file. And the WebAssembly text file is also executable. But let's see what we get here. Did I save it somewhere else? Where did I save it? There it is. All right, so I just didn't refresh the screen there. But this is the WebAssembly text format. And so we can see it's, we've got a whole lot of nesting and stuff jumped on, but if you've done assembly, it may look somewhat familiar and feel somewhat familiar. But this spec, you can actually write this WebAssembly text format. And I would rather work in a higher level language, but you can, and you can go down and get down and explore. And for our hello world, I mean, this thing is it's generated
wow
26,000 lines to do hello world, right? But there's some stuff that wraps around it as well, right? Like, because it's got to create some memory management structures and a couple other and some handlers to work with all of the different APIs and things that are available. But yeah, it's a lot to handwrite.
Vicky, you are too young for that. You are too young for that.
Yeah.
I'm not.
If you would have shown us this one the first time, we would be blown away.
So I'm actually reading a book right now to learn some of this. So there's a book, The Art of WebAssembly, and it's teaching this WebAssembly text format, and so I can learn a little bit more kind of about that base. But yeah, it's pretty crazy stuff. Now, one last thing I think that I'd like to kind of to show you guys and show you what we have available in this ecosystem now are. I mentioned you can write stuff in a number of different languages, and we get these WASM outputs, right? We get these WASM binary outputs. How do I take and use that? Like, because if I wrote a JavaScript, if I wrote a JavaScript script in JavaScript file, I could call that from other things, right? So how do we get that reuse? How do we get that collaboration and cooperation between stuff? And there's a gentleman who works for Fermion, which is a new startup in this WebAssembly space, who's been doing some really good blog posts on this idea. And so I stole a little bit of his examples here for this because it's already a really good example. What we're going to do is we have another Rust library that implements a in-memory cache. It's a really basic in-memory cache, and that we're going to expose as a library in WebAssembly. Now, to do so, we need to create this little this width file here. This is that's the interface, because Rust, we have to define how Rust is going to expose this this interface to WebAssembly, and how WebAssembly is going to marshal those properties and things back. And so it's just a little definition file that tells us about the exposed types. Now, what this reminded me of, so my background is a lot of PowerShell. And when PowerShell desired state configuration first came on the scene, we had to, when we created resources, we had to create these metadata files that told, that mapped PowerShell properties and PowerShell scripts to WMI data types. And that's what this reminds me of here. So this file just basically exposes what functions do we have, what are the function signatures, what are the data types that we expect for those things, and then in this case it's scaffolding out what are the errors that are going to come back, and what that then does is this library here, this bindgen here, helps us create the exposed those exposed functions in the WebAssembly that's generated. Now, we can build that, and in fact, I have. We've got a binary file here of Rust WASI implementation WASM. We could convert that to WebAssembly text file. And we could go and look at all the stuff that we just kind of looked at before. But let's see if we have, see if we can find our get here. Get. Gets too much. There's too many gets to go. That's not a great keyword to go looking for. But
so, just a quick question on that.
Yeah.
Is it kind of good idea to learn about that, or is it mandatory to learn about the assembly language, or is it just a good idea to at least understand it and then where things are being glued together, that type of thing? What's your thought on that?
I think it depends on your use case for WebAssembly. Now, in mine, I'm trying to go deeper into it because I want to dig into, okay, what's the debugging experience like? What is, what's the development experience like from a, I want to do more around the development experience for it, right? And then to see, because part of what we do in advocacy is we help build that end-to-end story, right? From sharing it and talking about it like here to helping build some of the components that help make that story flow, right? And so it starts from, hey, I want to run a WebAssembly workload? Well, okay, great. What happens when it's not doing what I expect, right? And I have a mix of development and operations in my background, so I have plenty of stories about, hey, this isn't working as expected, right? If your primary use case is I'm just building code to get something done in this environment, you might not need to touch the text interface. And if the tools get good enough on the client development side or on the development side, you may not have to know so much about it. Just let's parallel this to C#, right? Like if I'm building an application in C#, how much IL do I need to know? How much CIL or how much of the how much of the IL do I need to know, the intermediate language that my .NET assembly is compiled down to? Well, we've got decompilers that let us take and kind of and restructure back into almost into C sharp. It's not necessarily going to be the same thing that went in, but it's going to be the effective, similar effectiveness, right?
Yeah.
What if we have tools that are that good, and we have debugging tools that can attach to our executable and show me where in my source code I am, I don't necessarily need to know as much about the IL. Now there are going to be edge cases where I do. And maybe I'll be able to write more effective code if I know how the IL is being generated. In the same circumstance with WebAssembly. Except right now, the tools aren't as great. Because the tools aren't as great, it's more likely that you might be digging into something like that WebAssembly text format to figure out why things aren't the way you expect them to be. Awesome. That's one of the reasons I'm kind of diving into that.
Yeah, that's great. That's great. I mean, the thing is, like, for new dev that just wants to get in and just want to use it, how much sort of learning curve that they should kind of, obviously really good. That Yeoman and so on that you mentioned, that's pretty good. But the going through this WAT, it seems that there's a lot of development potentially happening around the debugging experience and troubleshooting, etc.
Yeah, when I first, a couple months back when I first started looking into this, I was really back in the world of print line debugging, right? Like where, okay, it got here, right? It got here and this value is that, right? Because when you're running in the WebAssembly gateway interface, for example, you're running in a WAGI implementation, the logs you have are the logs that are available via that. And that was standard in and standard out. So there was a lot of print line debugging happening because the way the code ran in WASMTIME locally was going to be different than how it ran in my hosting environment. And one thing, regardless of whether we're talking WebAssembly, we're talking containers, the first thing I like to do when I get into a new environment is learn about that environment. What are the environment variables? What does file system access look like? What files are actually present? And this could be if I'm going into the cloud, into a web service. For example, Azure Container Apps is in preview. I was helping one of my coworkers troubleshoot some stuff. So what does the environment actually look like? Because maybe there's some environment variables that are impacting the way our application is running. And so how do we actually go find that? So I actually keep a container whose whole purpose in life is to run print env, right? And when I run in a new runtime, whether it's Kubernetes, an Azure Kubernetes service, or running locally on a dev workstation, or running in Azure Container Apps, running in Azure Web Apps, right? Wherever I'm running that container, I want to know what things look like around me. And so we start to take a look at that. It's the same kind of thing in WASMTIME, and it's actually in the Hippo blog post. I go through like, hey, what does it look like to get that information, right? And it becomes a lot of print line. So I'm returning web requests with all of the environment variables and their settings, and hey, how does standard in look and how does standard out look, and understanding what that looks like.
Yeah, absolutely. That's fantastic. And one thing that you do in C# or any .NET stuff where you can just debug the code and just do it line by line and create a breakpoint and so on. So I'm assuming that that's yet to be available here, right?
Yeah. And so the debugging story is still pretty early days for WebAssembly workloads. Now, a nice thing you can do, for example, if I have, let's just go back to my, hello Azure tar experience here. If I have my, the right debugging stuff enabled, right extensions and things, I can go and set my breakpoint. I don't have it set up on this server here. I'm not going to do it while we talk, but I could set breakpoints in the Rust, and I could run it as a native executable and test it that way. Okay. And that way I get some of my debugging experience, And then I can use my collaboration with my print line debugging experience when I'm running in my hosting platform of choice. So we can take advantage of some of the things that we know, some of the things that we have available to us right here. For example, if I was building this in C# to try to target Blazor, maybe I'm going to run it locally as a C# console app to kind of figure out, is my code flow looking right, or is this related to WebAssembly or the runtime environment? Just kind of narrow down where that scope of problems actually is, because I might not have as great a view into my environment. So we talked about so we talked about the WASI implementation. I built. I've got a build of a capability I want to expose to other WebAssembly modules. Now, if I wanted to use that, I could use that from Rust, and that would be fine. And I can import that same text, definition file, and the bindgen will scaffold out all the things I need to call that. So it will create the code that I need to understand that, hey, this cache set thing, that is that other WebAssembly. Now you might think, hey, well, that's Rust to Rust. That's one would expect that to work, but it's actually Rust to WASM and then WASM to Rust. But we can go even further and go, well, what if I could build something in C or C++ and access that same cache capability from the bindings that are generated from, in this case, the bindings aren't being generated by that macro in Rust, but they were scaffolded out. There's a couple of tools that are available to help take that text file and convert it into the bindings that you need. So we've got this bindings cache H. Let's see what that looks like here. So that's just the definition saying, here's how C++ or here's how C++ would look at that WebAssembly that's being offered up. And we can run that. We can run that all in WASMTIME. And let's actually do that. All right, so let's change over into
just to compare, Stephen, it's like let's say many years ago, .NET developers, or you could call like a DLL, like a binary. You could another way to compare these with like Java native interface. But there's so much more code and more problems that we could have at the time. I think WebAssembly is more like a neat implementation of things that was we tried to do in the past.
Yep. Yeah, and you're hitting the nail on the head with kind of the problem that's trying to be solved. We tried to solve this in .NET. We tried to solve this in we tried to solve this in Java. We've tried to solve this in a lot of different languages, and all of these things have had like FFI, foreign function interface kind of experiences where you could call out to something that exposed a C API or a C ABI. And so, in Rust, I could call shared libraries that were written in C or C++. In .NET, I could call similar type things. I could also build stuff in Rust, for example, that expose that API that could call from .NET. Now, it can be a little cumbersome, but it's a very similar experience to this. But this is a little more streamlined because we're going to that one WASM, runtime, and all of these other things compile back down to that WASM runtime rather than compiling down to some other indeterminate format. So, and those other things aren't bad, and those other things serve a purpose, and they're great for the use cases they help solve for. but they're also targeting, again, the base machine. So that if we want to target that kind of standalone runtime, that's the difference that that WebAssembly is bringing in with this.
Mm-hmm.
So let's just build and link this thing, and then we'll run it in WASMTIME. Oh, I'm not in the right directory. That's why it's yelling at me because I'm not in my. Let's try this again. So it ran. If we ran WASMTIME and we enabled the module linking feature, and we mapped a file or we map a directory. So we're telling WASMTIME it can access this part of the file system, and that's it. And then to connect to the linked WASM, which is what we created, it'll output this linked WASM from my consumer and my implementation of the of that cache, and then it runs. It gets almost console, which is the thing I cached, right? And we see that in the code here. We're passing in the key, we're passing in a value, and then we call back and get it from there. Nothing too fancy or anything else, but what this is showing is that I can build an interface in one language that targets WASM, and I can consume it from any other language that targets WASM.
That's really good. That's really great. I can see that amazing potential in that. When you extend the support for other languages, it makes basically building anything with your preferred language much easier as well.
I think that's one of the things one of the main things that the success or failure of WebAssembly as an ecosystem hinges on, right? Like how effectively these things can be shared, and how well they're consumed. Because for me, I love this idea, and it fills me with dread, right? Because when I consume a library, say I'm building something in Rust, or I'm building something in .NET, or I'm building something in Ruby, right? I'm dealing with other packages that are in that same language. And so when I have to troubleshoot something, I'm maybe going into and looking into the code of the downstream component that I'm using, if I can. And that gives me a layer of comfort of, okay, well, I can at least trace the troubleshooting into that. When we're talking about WebAssembly, am I going back to, because we don't have great tooling yet, right? So am I going back to the source there, or am I stuck troubleshooting the WebAssembly text format, or what is that troubleshooting experience like? And that's the thing that has me a little bit cautious. But I'm more optimistic than I am pessimistic on where this is going to go, because there are a whole lot of smart people and a whole lot of eyeballs looking at this WebAssembly experience and approaching it from a number of different directions. So I think we'll get that problem solved. It's just a matter of kind of when and for what stacks first.
I think.
Go ahead, John.
No, I just say someone watching this, if you are interested to dig, you don't have to learn like assembly language or anything, but you can just scaffold one application and give a go and play locally, very lightweight. People used to do that in the past with many different languages. I think the old fellas were going to, people that used to do that on the 80s, 90s, like maybe Steve and I, and then going to enjoy that, because we used to hack like this text file and save the assembly back, the binary black. That's the way that you hack like assembly in the past. You do like a disassemble and you change the code and you save back, and you have your now, like MS-DOS with your name. We used to have hack the things and as a kid. But I think the message is a lot of ecosystem around that, Stephen, and it's growing fast. Probably it's easier to grow than like the container runtime. There's so many things that maybe the WASMTIME will be lighter and don't have a lot of things that we have to care inside like a container runtime. But I think both will be exist, and they will have different use case for those things.
I think it's a good hint for us to talk about kind of the future of this, or what your prediction about this, Steve, because I think we did mention it at the beginning of our call.
Yeah. I think the future really hinges kind of on that component story, right? What does the package repository look like for this, right? Is it going to be repurposing OCI artifacts, or is it going to be something else? And so how do we effectively share those libraries, and then how the debugging tools develop? To me, those are two of the key things. I think the use case will help drive consumption. I think that debugging and component story is going to help, and the tooling side of things is going to help create the developer story, and that will make I think that's going to make a significant impact on how well adopted WebAssembly. WebAssembly is going to get used in some places. How well it gets used, that we have yet to be seen. But I'm pretty optimistic. The one last thing I wanted to point out about if you use YoWASM to create your project, it's a great way to get started. It does scaffold down a README that has the instructions that were kind of spit out the command line as well, so you don't lose those. So it's not something that just kind of goes away from the command line. It's in the README in the repo. So you've got links to tools, instructions how to build. I didn't mention it does scaffold down some VS Code. So VS Code is your editor of choice. You have some tasks and things that are set up for you right out of the box. But that's pretty much that's pretty much my my understanding and my experience here in the WebAssembly space so far, and it's been fun. And I think there's a ton of room to grow. One thing I regret is not looking at the container space earlier when it was smaller and I could get a quicker grasp on things. When I came to the container ecosystems, right, there was so many things going on. It was really hard to kind of drill down to find those core basics. And what are the core things I need to understand about this, right? And then, so that's why I suggest look at even if you're not going to build a bunch of stuff, build something. Just get an idea of the main players and the main moving parts in the WebAssembly ecosystem, and file that away in the back of your mind and watch as that ecosystem evolves.
Sweet. That's really good. I guess last thing, and probably if you could share any, valuable links that we should sort of keep an eye on around the WASM, WASI, and you mentioned WAGI as well. Around that'd be really good, I guess, for the rest of the community.
Let's put on the description, Vic. Let's put on the description of the video, and I think I got it to the end. For this first part, we're going to bring Stephen back for sure. If you are happy with that, Stephen, we really enjoy to have you here. And
my pleasure.
Thanks a lot for that. It was a lot of very deep knowledge information there that you are building and learning from now that you are part of our cloud native team. I'm very excited to be work with you. And like Vic said, we discussed before here, 2015, when you talk about containers and like isolation of like a process, was something far behind, like away from a lot of people. People don't see that. I could see that happening in 2016 when I met like Brendan Burns, and I said, wow, there's something new coming here that I haven't seen for a while. Things like maybe DLLs or Java native interface or C++ that I used to be a C++ developer. And maybe that's because this background, I could see that happening. And WebAssembly was, gRPC, things like that was my subject that I'm following since the day one. Containers, gRPC, WebAssembly, because changing the way that we communicate, and sockets and things like that. And it would be amazing to have sockets on this.
Yeah.
And I'm looking forward to learn more about that. Thanks a lot for Vic for being here with us.
Thanks a lot. You saved me hours sort of going through kind of the basic understanding of WebAssembly and so on. So that helped me a lot, and really appreciate the deep insights as well about this. And I can see this is a really good opportunity for a lot of folks to kind of get in before became really crowded, like what you said before around containers, right? So if obviously it hinges on those things that you mentioned, but when it becomes popular, you know that you kind of ahead of the curve.
Yeah, just build that a little bit of that familiarity. And yes, George, I'd love to come back and spend a little bit more time looking at where we can actually deploy WebAssembly runtimes today and hopefully in the future. So, but yeah, it's a cool space. I really appreciate the time that you and Vic have spent with me.
Thanks a lot, Steven, and thank you for watching. Follow us, because we're going to be bringing out more maybe Microsoft advocates, people like engineers, from the teams to talk with us and maybe go a little bit deeper than we normally do and have like an open conversation, bringing questions. And look forward for the next video. Thanks a lot. See you soon.
Thanks, guys. Everyone.